Well, welcome to OSE 541. I can say that this is a very interesting topic. It's like a dynamics, which means everything is in motion. That motion is not like a classical type of the motion, like a sinusoidal or the regular wave. This is somewhat different, so which is called stochastic motion. So stochastic theory, I just put the name, such a name on it. Stochastic means it does not follow particular pattern in the time domain. And in the frequency domain, it may not follow the particular pattern. So random, I feel whole nature, whole natural phenomena in the world is random. Strictly speaking, it's a random. So a special case of a random process or time histories or time domain problem, you can say that's a deterministic. Deterministic, whether you like it or not, you have to follow the particular pattern, which you could call the classical pattern. But stochastic doesn't follow. So that's the beauty. But some class of the stochastic process follows particular pattern, not in time domain, may not be in frequency domain. That's what we mostly are using it. It's mostly using time domain or frequency domain for any engineering problem. Control problem, very similar. But for the randomness, some class of the random process, it follows particular pattern using the statistics. Statistically, in other words, statistically, it follows particular pattern. So if you listen very carefully what I say, you could say, geez, Professor Shin, what are you talking? You said, follow particular pattern. Doesn't follow particular pattern. My answer is yes. That's why you are here to learn. So if you fix your mind, you can solve the problem. Okay? You have to really open your heart. I mean it. In the whole graduate study, I want you are such a brilliant, you have a brilliant mind. I want you to open your heart, open your mind, then you can accept whatever is coming into your heart. Okay, if you, some of you could say, oh, I have never seen that before in my life, then if you cut off, who lose? You lose. Because you already excluded particular class of the problem. But not only for this stochastic theory of a structure system, stochastic, but just to let it happen and see what the consequences would be. That's more, and that's very important than just solve a particular problem, then happy and go out, do something else. No. I would rather see you really generate your creativity using your inner mind. Inner. So in other words, everything is random. Okay. Acceptable. We're going to start right there. Not the regular sine wave. No. Or some sort of the regularity in the wave you want to deal with, then you want to find the law. That's acceptable. In the randomness, it's not acceptable. Each phenomena is different. You measure the wave motion at the 0 time, then you record for an hour, then you came back at the same time, same location, you measure the same, let's say, the wave height, then the one I measured yesterday would be quite different from the data I recorded today. So every day's measurement could be different. But you could say, that's random. My answer is yes or no. You see? So that's the beauty. That's the beauty for the random phenomena or stochastic phenomena. So stochastic, how many of you heard about the stochastic in the past? How many has a course, like a statistics course or probability course? How many of you have it? 3 of you, 3 or 4 are working for a doctoral degree, right? That's great. Well, anyway, welcome to the class. I know I heard you have about 2 weeks to decide whether taking courses or not. The way I teach the course, easily speaking, I can say my course is not difficult. That doesn't mean that, well, I don't have to study. Then who lose? You lose. I don't lose. But I give more freedom to think. I don't want to confine yourself to a particular term project or heavy homework, then you wouldn't have any time to think. That's the worst thing I can do. I don't do that. But I like to really change the style of learning. Whenever I take an elevator down in the morning about 8 o'clock, sometimes 8:15, a lot of youngsters coming in the elevator to go down to the first floor. Then I always say, hi, how are you? How's your work? You know, they are really so miserable because I saw them in the morning, I saw them coming home, then I saw them sometimes late in the evening. They're all in the hagwon all the time. I call that as a miserable situation. They don't have a time to think, but they have a time to memorize. Everything has to be memorized for such a young age. Eventually that will bring them and no thinking, no creativity. They just don't have a time. Whatever the teachers provide, they have to take it. And not clear, even if the things are not clear, they have to memorize it because it's coming in the exam next day. So memorization is the worst thing in the classroom teaching and learning process. So some of the fellow teachers also mentioned, well, how come you like PowerPoint? I don't want to, I have my own philosophy. I don't want to see you spending time after time to copy the stuff which I want to present, but I would rather discuss about the philosophy. I really like to see about what's out there in the world to discuss about it, rather than, hey, you copy this, follow me. I don't want to do that. You do that, I don't want to do that. So that's the direction I want to do, okay? And of course, all the engineering process you have to learn. Together is the better things than you do and submit, then I'll grade it, then I'll declare whether it's right or wrong. I don't want, if I like that, I wouldn't come here. I want to see some new things here. In the randomness, I want you might open another big tunnel, then you can bring some beautiful lights that everybody can share. And randomness can be beautifully explained or expressed using, of course, statistics. If you did not take at least one statistics course, I could say you must take at least one course. Because randomness, you cannot explain without the statistics. Because as the name said, it's so random. Okay. So that's the situations you are in. But in this course, some of you mentioned you never took the statistics course. But undergraduate, you might take the statistics course. Chongwon, you took one? I think you must take at least one statistics course before you graduate, right? Youngwon, did you take? Here. Are you going to take the statistics course from KAIST sometime before you graduate? You must strongly say yes. Otherwise you can't graduate. Only they demand one. Two is better than one. But for of you who are working on doctoral degree, even if you may not take the random vibration type, the stochastic type of the work, but still, good idea. If you are going to win in the stock market. Stock market, they always put the statistics ahead of everything. There is no absolute 100% winning. It's always based on the probability. So that's what the randomness or stochastic process here in stochastic theory of structure system. I put the word structure system in a sense. Structure system behave much better than what you think. Because I think the God made maybe that way. Yeah. Even if you really introduce the randomness in, let's say, loading. For example, wave. the platform, oil platform in the deep oceans hit by the wave trains, which is really random. That platform, oil platform, behave like a regular kind of predictable kind of the behavior, dynamic behavior. It's really weird. When you're really hit by the sea wave, which is really random, but when you take a measurement for that platform, the dynamic response behave like a classical or regular dynamic response. So how it happened, why it happened. So that's sort of the thing you can think through this course. Not only just that. So to do that, you've got to understand what I propose to learn. This is proposed. It's open-end process. So first time I learned this, the stochastic analysis of structure system, it was 1969. I still have the textbook. 2 textbooks were available that time. I have still here. I brought here. I didn't bring that when I came in a year and a half ago, but when I went back to see my children last December, I went back to my office in Naval Postgraduate School. Then I took it and brought here. There are about half a dozen good books, and I'll show you. I have all that books here. You can readily check out for a day and bring back, preferably before the end of the day. You can read it, then bring back, then you can check out again tomorrow. You can bring back. But if you need a few days, I have extra books also. Then you can come to my office. You can check out the book even for a few days. Okay? I don't think you really needed to buy the book. So here, let's go through what I'm going to talk to you throughout the course. Might be you should have interest in and learn together. You know my office, 3rd floor. Chabam, where is your office? 3rd floor? 1st floor? Your 1st floor? Oh, you are also part of STX? Wow. STX. A lot of people will go back to STX. Okay. Yeah. You are not STX. You are STX? You? It's good. They pay, STX pays, I think, good scholarship every month, and job is secured after you graduate. So, in a sense, it's good. As I look at all that shipbuilding company, frankly speaking, I like STX the best. Very aggressive company. We have a chance to discuss the president for that corporation. Based on his talk, he gave young people all the freedom. When I say freedom, more time, no. Whatever they want to do, then the top guy accept rather than reject from the beginning. So in that sense, is a very, very good company. So, Hyundai, good company, very conservative. Very conservative. So that means you have very limited the environment you can maneuver. STX, as I felt, is my personal opinion, is more kind of the space environment I can really perform. And lecture hours, Monday, Wednesday, Friday, 1 o'clock for 50 minutes. And sometimes I might be away, at least as of today, I know I will be away for 1 week, starting with March 14. I'm going conference in Tampa, Florida for a week, and that would be it. So then, of course, 3 hours I will make up the lectures. Usually, right at 6 o'clock, 6 p.m., and for an hour. Sometimes I'll give 2-hour makeup class. Things like that. So if you have such a situation, let me know. So sometimes it's necessary. So this case, I usually don't travel when I'm teach, which means only the summer and January I usually go away. But sometimes you can, so we have to. Whenever you have to do, you let me know. Then I'll try to give you absolute minimum damage. Okay? And this course is designed to provide a full understanding of stochastic theory of structure systems and also applications to engineering problems. But there's an infinite number of application problem, but I'll do a few, you do a few, we have to solve some problem. I'll solve easier problem, you solve harder problem or difficult problem, vice versa. And topics include random variables and the stochastic process. I said random variable and the stochastic process. Usual understanding is like this. As we talk, you'd understand better. Random, when you hear about the random, which is really, strictly speaking, this is really stochastic. There is no difference between the random and the stochastic. It's really identical. But the usual way, random variables. Random variables, when you hear the random variable, usual understanding is in the probability space. Probability can be expressed as one variable, like the student's height in this class, for example. So random variable is one, height, okay, for example. Or some phenomena may be explained using 2 or 3 or 4 kind of the variables. So usually talking, when you hear about the random variable, you are really talking the static kind of a variable, no dynamics. Okay, for example, x is equal to something. X is a function of time t. It's in engineer's mind, it's already time domain parameters are involved here. So you can say that already, wow, this is really not the one particular the variable. You're talking about the history, time history type of the dynamic motions. So which is really, you call in this case, if it's the random type, is called function. This case is just a one. This is time t. This is like xt. You saw all this kind of all the time. By the way, the teaching assistant is Woo Hee-gyu. You all know him, right? So he's going to assist me for this course. He will send you the chapter 1, including this chapter 1, so you can read ahead of the time. Very easy to read. If it's not something not clear, then sometime I will provide all the solution. Sometimes I'll assign that problem that you can solve at home. Function. So it's not variable. Random variable could be the point. Random variable. 1 point is a different. So this is like a function already. Okay. As I mentioned, wave height you measure this morning, tomorrow morning, the day after, things like that, then you will get, in this case is height. Height is h t. First day. Second day, you could have h2t height. And you could have a whole slew, depend on how many days you go out, take a measurement. This whole thing is called ensemble. It's a name. Ensemble. Like a group or family. You're dealing with a family. So which you could call that HT. When I put the bracket here, parenthesis there, is talking about such a family. Okay? We're gonna deal with that. So it's a different random variable, one particular point. This, in this case, is ensemble. It's a group of random function even. Just one particular time history, for example, is a function. But it's random because this function, like x here, it varies. It can vary. There is no possibility for predicting that, like a time domain kind of a history. Sometimes today it may be confusing you a little bit because you came into the room with the really fog here, you can't see like this morning. Fog is so much you can't really see well. But now, as the fog starts to clear up, then you can see it. You can identify yourself, a lot of different things. Then you can feel those satisfactions and joy. Okay, that's what I want to say that. Okay, so topics include, as I mentioned here, I'm going to just pull down the same thing, repeat here. I'm going to do 1 week, 2nd week, 16th week. I must write, but I might update as I keep teaching and change or add or drop. Okay, but main flow is this. So something like today is really roadmap for the spring semester. And of course, I'm going to talk to you about the probability, basic probability you need. So of course, I'm going to do the variable probability, then joint probability. I'm going to talk about the ensemble average, all such things. Then Fourier series and the Fourier transformation. You took all such courses, don't you? How many of you never take Fourier transformation? In the class, you and I will just talk anything, okay? Then it stops here. So it's very important to know each other, okay? So like a Fourier series, a Fourier transformation, that's the beginning of really engineering, solving the engineering or engineering itself. So I'm going to go through that. But if you have that already, has a full understanding, it's going to help you. So Gusto, in Indonesia, you spend in class for Fourier transformation stuff. Do you recall that? Yeah, the vibration class. How many of you took the vibration? I have to know what's in your heart, right? So then easy, then I can really handle you very nicely. Right? But how many of you took the vibration class? Undergraduate, graduate? Oh, that's great. But Zhongwan, you are the specialist in vibration. All the vibration, that is very easy. But still, some of you may take the course maybe 2 to 3 years ago. It evaporates, but doesn't evaporate forever. When I talk, it's all coming back very fast. But if you didn't take the course, it may not come back too fast. Or some come back, some don't. So as I see you, all of you now, you took the vibration classes already. So think this way. This is like a random vibration. There has been books, I show you which book. It's random vibration book. Okay, random. So Fourier series, 3rd week, Fourier series and Fourier transformations. I said the 3rd week, week 3, but could be week 1 or week 2. So Just leave such a thing, scheduling to me. You sit back, just fill up your heart with the knowledge. And fourth week, physical system response properties. I'm going to go back to vibration point, get transfer functions or frequency response functions. You can put the random excitations, then see what kind of output response you expect, vice versa. And week 5, stochastic process in time domain, and time domains such as autocorrelation function and cross-correlation function. So time domain problems we're going to deal with. And week 6, special probability density function or distribution function. There are a lot of useful probability distribution function and density function. For example, one is the most popular. Which one is that? You heard about the normal distribution function? It's a symmetric upside down bell shape. Remember? Yeah. So whenever I present, I always give a good background, then introduce, then use it. So you don't have to worry about it. And sometimes that is called as a Gaussian distribution function. Okay? It's a symmetric density function, but there are lots of other functions which explains different phenomena. It's called extrema distribution function, which is something like log normal distribution, which has skewness of the distribution function. The reason I said skewness, normal distribution, you cannot give a skewness in the population, but Rayleigh distribution or log normal distribution, Weibull distribution has a skewness to express the given probability density function. So that stuff I'm going to address on that, okay? As simple as possible. I really hate to read very thick novel you call any book. If it's too thick, I just hate it. I can't just read a 1100 page book. Gosh, it's terrible, isn't it? I'd rather have a very thin book. I'm talking textbook. Thin book. Then you can expand the next, when you study more, wants to do more, then you can really getting into deeper. From the beginning, if you say thick, like a Bible, then you turn the first page, all that family history, at the second page I close. Too much to read, all that family trees. I'm not saying don't ever read the thick book, no, but that's what reality is. 7-week Fourier integral and complex Fourier. It's at the beginning I inject to you some good knowledge on this. Inject a little bit like an appetizer. So then a little bit later I introduce again to look at different perspective. Appetizer is very good to really raise the appetite. I visit VIP, you call? Restaurant? VPI? VIP? Bips. Bips. Oh, you know, Bips salad bar. That's excellent. Then you just go enjoy all the salad bars out there. If you ate too much, then not good. You can eat just a good steak or something else, you know. So here a little bit, here. That's what the usual plan is. So autocorrelation requires cross-correlation. That's time domain function. Then you throw into the frequency domain function, which is called week 9 cross-spectral density function, power spectral density function. You all learned, I bet, maybe. But to really explain the one-to-one relation between the time domain problems and the frequency domain problem. Why do you want to learn both? For the given random function, when you generate so-called autocorrelation function, then I throw into the frequency domain and generate the power spectral density function. You should have a reason why. Right? Not just for fun, or not just say, oh, Professor Shin gave the homework problem, then he said do it, then I must do. Not good. But if you really want a good grade, A++++, then you let me know. Okay? That should be the right way. But otherwise, why? Always ask yourself why. Why? Why I have to do this? That will generate your mindset in different way. Because why? This is called the cross spectrum or power spectra. Is a Fourier transform of autocorrelation function is power spectra. Why do I have to know this is the frequency domain spectra? To see the frequency content. What's the reason to look at the frequency content? Whether you want to suppress the particular signature, what do I have to do in terms of the frequency, vice versa. Sometimes you want to suppress the high frequency region. Sometimes you want to suppress low frequency region, vice versa. It has a reason, and it has to have a reason to achieve particular goals. That's what you need to understand all the details. So you look through this from week 10, some applications started coming in, like level crossing problems and transmission of random vibration 12 week. 13, revisit classical vibration problem set subjected to the random environment. Then how to handle the random problem on multiple degrees of freedom system. So you are the core of a finite element approach method. It's multiple degrees of freedom system. Then you deal with the stiffness matrix. When you're getting into the dynamic problem, then you have to deal with the damping in the system plus mass matrix in the system. What happens if there is a variation in random nature? How to attack the problem to get the solution? Immediate problem. oh, that may be a good parameter to work in your thesis as a part, not the whole. What should I do? I have a randomness. Material property could be, has a random variable in there. Young's modulus. Yield stresses has a randomness. How to handle that? So that's it. I have about time look like, and that's what. So the last couple of weeks, I have introduced more applications of use of the random problem set. So today is first day. I just talk a lot of different things to see your heart opens a little bit. So at the end of today, now I see your heart is slightly open, not quite yet. But at the end of this week, your heart may be open more, a lot more. Then I can really work out and do a little bit more. Okay? And check your email. You should have chapter 1. So I'm going to march that from Wednesday. Okay? Okay, welcome to random class. Okay, have a good day.